about network models. We're going to use QM for Windows, although I'm going to show you how to do a couple of these manually. You don't have to. One is called minimal spanning tree, the other is maximal flow, and the third one is called shortest route. Now for minimal spanning tree, what we want to do is connect all the points in a network together, but we want to minimize the distance between them. You can follow along problem 714 on page 301 if you'd like. What it says is that this company wants us to connect video cameras to a main control site, but the link must be in a cable that's super expensive. So what they want to do is they must connect all five, but they want to use the minimum distance for the conduit since it's so expensive. And this is what it looks like. Here's the all of the nodes from 1 to 6, and we want to connect all of them but minimize the distance. So if we can do this manually, it's not that difficult. What we do is we select any node in the network, and let's say I select node number 1. We look at the nearest node to number 1 that minimizes the distance. So look, number 4 is 75 miles away. Number 3 is 65 miles away. Number 2 is 50 miles away. So that's the smallest. So we're going to count that, and we've considered 1 and 2. Then we look at each node that we've considered, and again, pick the smallest. 1 to 4 is 75. 1 to 3 is 65. We already picked 1 to 2. 2 to 3 is 37, so we're going to select that. And then you look at nodes 1, 2, and 3, select the smallest one. That's going to be 26 from node 1 to 4. And then you look at nodes 1, 2, 3, and 4. Select the one with the minimum distance. That happens to be from 3 to 5, 41, and then 4 to 6 is 23. So we did that manually. It's not too bad. It goes from 1 to 2 to 3 to 5 to 6 for a sum or a total of 177 miles. That is the manual way of doing it. Now what we could also do is go to QM for Windows. You notice I go up to Module, go down to Networks. When you click on Networks, you're going to get the 3 techniques we're interested in. We're doing this one, minimal spanning tree. So we click on minimal spanning tree. When we do that, we have this table. And you notice we need to put down how many branches there are. You count the branches, there's 10 of them. We need to indicate the start and end node, like 1 goes to node number 2, number 3, and number 4. They're here. And we have to put the values in. This happens to say cost, but actually it's, in this case, it's distance. And that 750 that you see right here, by the way, is incorrect. It should be 75. And you enter all this data in, and then you hit solve up here, where it says solve, and the QM for Windows minimal spanning technique comes through, and it shows you the starting and ending nodes, 1, 3, 4, 5, and 6, and the cumulative distance here, individual distances plus the cumulative distance for 177. Same thing we got doing manually. So depending on how many nodes you have, it may be beneficial for you to do it manually or using QM for Windows. Now for maximal flow, what we want to do is determine what is the maximum flow that we can have through a network from left to right, from east to west. And the way we're going to do this is we're going to, let me show you the nodes. There they are right here. We want to go from 1 to 7. Now we want to know this happens to be thousands of gallons of fuel, which the maximum amount of fuel we can transport from 1 to 7. And you notice that the numbers on the paths there, the first number, like a 4 here, is the maximum capacity from 1 to 2. And this 3 is the maximum capacity from 2 to 4. But we also can have reverse capacity. From 2 to 1 is 0, and from 4 to 2 is 3. So every branch here has two capacities, one forward and one in the opposite direction. So what we're going to do is pick any path from the start 1 to the finish 7, any one. And like I picked 1, 2, 4, 7 to start with, I believe. Yeah, 1, 2, 4, 7. So 1, 2, 4, 7 goes from right here up to 2 to 4 and then down to 7. So what we're going to do is we're going to look at the forward flow capacities and pick the minimum one, which happens to be 3. And we then subtract that minimum one from all of the forward flow capacities. And we add that minimum to all of the reverse flow paths. Now you notice, to begin with, from 1 to 2 we had 4,000 gallons in this direction and none back. Well, you see the same capacity we have after doing this. We had 1,000 gallons going from 1 to 2, but we have 3,000 from 2 to 1. So the capacities remain the same on each branch. So what I've done here is I've rewritten the 1, 2, 4, 7 branch with the correct forward and reverse flows and indicated that the capacity C for that branch is 3. Then what you do is you go to another branch, and this one is 1, 2, 5, 7, 1, 2, 5, 7. But remember, 1 and 2 have changed. Their forward and reverse capacity changed from the first thing that we did. So what we have now is forward capacities of 1, 3, and 1, 3, and 5. 1, 3, and 5. The minimum, again, is 1. And so we're going to subtract the minimum from every forward flow, and we're going to add the minimum to every reverse flow. So what we have now is 0, 4, 2, 1, 2, 1, and 4, 2. And our capacity for that branch was equal to 1. So we did 2 branches, capacity 3, capacity 1. And you just keep doing this. Now, as you can imagine, it does get time consuming and complicated. It could be complicated. So what we're going to do is use QM for Windows. We have to determine how many branches we have by counting them. And then we fill in this data. Start node is 1, end node is 2. The capacity in the forward direction and the reverse capacity. All this information we have to fill out this form. Once we do that, we hit solve again, and you notice that what QM for Windows will do is it'll show us the capacities of each branch that we have. Each branch that we have, it'll show us. And down at the lower right here, you see we have capacities of 5, 3, 1, and 1. We did 2 of those. And the cumulative is 10. So we can move 10,000 gallons. 10,000 gallons, that's the maximum flow through that network. Okay, the next one is shortest route technique. The name implies what it is. You want the shortest route from east to west, point A to point B. Again, here's a problem on page 301, 711 you can look at. It involves this moving company. They're going to move to their new headquarters, and so they're going to move from the old office number 1 to the new office number 13. They have a variety of routes to take, and what you want to do is pick, obviously, the shortest route. And so you find the nearest node to the origin. So the origin is 1. The nearest node is 4 because it's only 40 away. Okay, and then you put that distance in a box by the node, and you just keep doing this until you get the shortest route, 40, 20, and so on and so forth. Well, again, I prefer using QM for Windows for this. This is a rather complicated one. There's 20 roads we have to consider. We have to fill in the table with start and end nodes and the distance between them, right from our diagram. We hit solve, and here's what it shows. It shows that the total distance is 430 miles, and it tells us how to do it. We go from 1 to 3, from 3 to 5, 5 to 7, 7 to 10, 10 to 13. That's the shortest node. Remember, for this one, we don't have to hit every node. Well, all we want to do is find the shortest path between point A and point B. So you see, these aren't too difficult. You just have to, take your time to do them, understand what the techniques do for you. Pretty self-explanatory. And again, make sure you remember these dates. And in Unit 7, you can email me, although we're